Hi, my name is Roger, and this is the midpoint update for the project, Memory Management Assistant based on Knowledge Graph. We've made great strides, including implementing the ability to add and query knowledge, integrating LLM-based processing, and providing full functionalities for managing memory files. On top of this, we've refined the UI to ensure an excellent user experience. Let me briefly recap the purpose of this project. Researchers often struggle with managing diverse and complex information, papers, experiments, notes. It can be overwhelming. This project aims to address that by assisting in information storage, retrieval, and visualization so that researchers can better understand and utilize their knowledge. So, what can our assistant do so far? It enables researchers to add, manage, and query knowledge effectively. Unlike conventional tools that deal with entire documents, our system breaks down information into such small units that can eventually be represented as vertices and edges in a connected knowledge graph. While the graph integration hasn't been implemented yet, it's on the roadmap. Researchers can query the stored knowledge using the memory context they provide, which is also planned to achieve by graph relationships, but is now processed by LLM. If there's something they want to adjust, researchers can easily edit the memory files with full control. Now let's talk about the tech. As described before, our backend is powered by Flask and integrates with OpenAI's API for LLM-based processing. The front end, built with React, can handle user interactions like choosing add or query mode, inputting text or files, selecting memory files, and adjusting model parameters. The front end sends these inputs to the backend, fetches responses, and displays all interactions beautifully. So why not walk through a quick demo to showcase what we've built so far? Imagine you're working with a research paper on colorectal cancer. From the sidebar, select the model to use, the context size, and the number of pages you want to process. This ensures the input stays within token limits. Choose an existing memory file to store the extracted knowledge, or create a new one. Now simply upload the paper. The key points will be extracted and stored. If there's anything you'd like to adjust, the memory management window lets you edit the file effortlessly. To retrieve knowledge, select the relevant memory files, type in your query, and hit search. The system uses the LLM to process the query in the context of the selected memory. Want more flexibility? You can query the LLM's own knowledge with a click. While Query Internet isn't fully implemented yet, the plan is to use Bing Search API to scrape text from the web, process it into structured knowledge, and integrate it. Moving forward, there are several challenges to tackle. First, effective internet querying, which we just talked about. It could be hard to effectively extract useful knowledge from scraped text, so I will probably research on how current internet-enabled LLMs handle this, or directly integrating APIs of those LLMs. Another big step is constructing a robust knowledge graph. Neo4j's LLM Knowledge Graph Builder API will be used to extract nodes and relationships from unstructured text, turning fragmented knowledge into a connected, visualizable graph. And as the project evolves, advanced development can include refining the LLM prompts and models. Lastly, for potential cloud deployment, I'll need to address some concerns about data security, user isolation, and scaling the system to handle concurrent requests. It's a challenging road ahead, but it's exciting to keep pushing forward. Thank you for your watching, and I look forward to showing you more progress next time.